So we're going to look at a series of problems of improper fractions which we are going to integrate. Now, as a reminder, for the improper fraction, all that means is that in the numerator the power is either greater or equal to that of the denominator here. So in order to do this, first of all, we're going to need to divide the expression by the denominator and then simplify it. So for the first one, we're going to do x plus 1 divided by x minus 3. So a little bit of algebraic division. X divided by x is 1. Multiply through, so x minus 3. Subtract the two expressions, the x's cancel. 1 minus minus 3 gets us plus 4. Now that the power of x in this is less than the power of x here, that's fine, we can stop. And all it means is we can rewrite our expression as 1 plus 4 over x minus 3, which we can now integrate with respect to x. The integral of 1 with respect to x is x, and we have a constant over a linear expression, so we're going to generate a natural logarithm plus 4 times the natural logarithm of the linear expression x minus 3, and because this is an improper fraction, we also need plus c. So that's our expression for the first one. Similar idea for part B. Again, the power in the numerator is either equal to or greater than that in the denominator, so we need to divide first. Two x divided by x is 2. Multiply 2x plus 2. Subtract, the x's cancel. 4 minus 2 is 2. The highest power of x here is less than it is the thing that we're dividing it by, so we can stop. So really we are going to integrate 2 plus 2 over x plus 1 with respect to x. So when we integrate this expression then, with respect to x, we have 2x plus 2 times the natural logarithm of x plus 1 plus the constant of integration c. So that's our expression for part B. And then a little bit more work to do in part C, but again, the highest power in the numerator is either equal to or greater than that in the denominator, so we need to use algebraic division first. Two x divided by 2x gets you 1. You multiply out to get 2x plus 1. You then use subtraction, the two x's cancel. 2 minus 1 is 1. So you can rewrite the expression between 2 and 1 as 1 plus 1 over 2x plus 1, which we are integrating with respect to x. The integral of 1 with respect to x is x, plus the integral of 1 over 2x plus 1 is the natural logarithm of 2x plus 1, but you can't forget we also need to divide by the differential of that linear expression, so we need to divide by 2. We don't need a plus c for this expression because we have limits of 2 and 1. We need to substitute in our upper limit first, so 2, to get 2 plus the natural logarithm of 2 times 2 is 4 plus 1, 5 all over 2, minus sign in the middle, 1 plus the natural logarithm of 2 times 1 is 2, plus 1 is 3 over 2. You have 2 minus 1, which is 1, plus there is a common factor of half times the natural logarithm of 5 minus a half times the natural logarithm of 3. And let's just combine this together then. So we've got 1 plus a half times the natural logarithm of 5, because this is a minus, divided by 3. And that is the form I'd leave the last one in. It's about the nicest form.